Welcome back to Calculus. This is homework set number 6, problem number 5. Okay, and it looks like we have a distance between the point and the line of 8 square roots of 13 over 13.
For this problem, we're looking at how close does a line come to a point, or how close does a point come to a line, either way you want to think about it. So here's what we've got. I'm going to draw out the picture of the line and the point. So the point's the easiest one to do. So the point is 2 over 5 up. Okay, so that's the point. Now let's take a look at this line. Probably the easiest way to get an idea of what this line looks like is to find its intercepts. Okay, so if x is 0, that's going to put us on the y-axis. And so if x is 0, this guy becomes 0, and this guy would have to be negative 2. Okay, so 0, negative 2 is a point on the line. Okay, if y is 0, this guy drops out, and then x is 4/3, or 1.3 repeating. So when x is 1.3 repeating, y is 0. So we've got our 2 points for our line. Let's go ahead and draw in the line as best we can. Okay, so there it is. Now we want to know how close does this line come to this point. So the closest it's going to come is this guy right here. A straight line dropped down, right? Because as soon as I go out any distance besides straight, you can tell already that those lines are going to be longer. So what that means is if I drop an altitude down from the point to the line, making a 90-degree angle, that's going to be the closest that I can come. So now the question is, what is that distance? Okay, well, to find the distance, what we need to do is we need to find the point here. Okay, we need to find the point that's the shortest. So there's a couple approaches that we can use. Okay, probably the easiest is to go ahead. So I'm going to say, let's let this point right here be arbitrary. We'll just call it x, y. We don't know what it is, okay, but we're going to find its coordinates in just a second. Now, one of the things about this is that this line contains this point, which means that since this can be substituted in here for y, we know that if I move this 2y over, we know that 3x minus 4 is equal to 2y. And we also know that y is equal to 3x minus 4 over 2. So since y, these y's are the same, this is 3x minus 4 over 2. Now why would I do that? Well, I only want one variable because I'm going to show you how to get just one equation. The distance between this point and this point right here has to be minimum, right? We want it to be closest. So the distance formula says the distance between here and this point is the square root of the difference of the x values squared plus the difference in the y values. Just like that. So we want this guy to be minimized. So one way that we can do this is we can go ahead and work the math out here. You can do this all out algebraically, but the problem that you're going to get, we want this to be as low as it possibly can get. And so we need a little bit of calculus. Okay. The other way that we could do this is we could take this guy and we could graph it out on our calculator. Okay. Another approach. Okay, so we could graph this guy out and we could look for where it's at its lowest point. We can do that all out with a computer system. But here's an interesting thing. Since this line makes a 90-degree angle with this line is perpendicular with this line. So the slope of this line right here must be the opposite reciprocal of the slope of this line. Well, what is the slope of the green line? Okay, so the slope of the green line is going to be equal to 3/2, right? Because I'm going to get it from right here. So it's 3/2. So that means the slope of the white that's going to be equal to -2/3. Now we've got this line, we know this line, watch, because we have a point on it. So y is equal to -2/3 x plus b, the 0.25 is on there. Okay, so this is 5 is equal to -4/3 plus b, add 4/3 to both sides to get our b value here. So that's 15/3, so it'll be 19/3. So y is equal to -2/3 x plus 19/3. So what does that give us? Well, what we need to do is we need to figure out when does this line intersect this line. So when they intersect, their x's and their y values are equal. So what we need to do is we need to solve the following. We need to solve, if the y values are equal to one another, then that means that 3x minus 4/2 must be equal to -2x plus 19/3. That's what we got to solve. So we'll go ahead and work through this. What is this going to give us? It's going to give us the x value right here that we're looking for, where they intersect. So if I just cross multiply here, I'm going to get 9x minus 12 is equal to -4x plus 38. Move the 4 over, gives me 13x. Move the 12 over, gives me 50. So x is equal to 50/13. Okay, so, 50 over 13. And so then what's the y value? Well, we take 50/13 and we plug it in for x. Do it in either one of these guys because these are all equal to y. So let's do the first one. So that's going to be 3 times 50/13 minus 4/2. That's 150 minus 52/13/2, which is over 26. Okay, you should think about how I just got that. So that's going to be 98/26. Both these are divisible by 2, so that's 49/13. Okay, and there you go. Those are your values. Okay, oh, sorry, I should say those are your values. That's the point. We're not done yet. That's the point right here. But we want to know how close does it come. So we need to do the distance formula with 2/5. Okay, so we've got one point at 2.5, and another point at, let's see here, what are we at? 50 and 49. Okay, so the distance is equal to the square root of the difference in the x's plus the difference in the y's. And this is actually irrelevant which way I go, so yeah. Right, because we're squaring, so the only difference is one will be positive, one will be negative. With the square, we'll get rid of it. So this is just algebra, I suppose we can work through it. So 50/13 minus 26 over 13 squared plus, now I gotta get this guy over 13, so that's 65 over 13 minus 49 over 13. Okay, so keep working this guy out. So 15 minus 26, let's see here, 24 over 13 squared. 65 minus 49 is, let's see here, if I go 20, no, that's going to be too much. So if I go 10, 16, it looks like over 13 squared. So when we go ahead and reduce this, it's going to be kind of ugly here, but 24 plus 16, so I've got 832 over 169, the square root of that, which is the square root of 832 over 13. 832 is certainly divisible by 4. Bet you it's divisible by 16. I wonder if it's divisible by 32. Nah, I don't think it is. Oh, it is. Okay. So there we go. So that's going to be, 32 doesn't matter. I needed 36. Let's see here. Well, 832 is definitely divisible by 16. And then I've got 52 left over. I don't think any perfect squares go into, except for 4 again. So it must be divisible by, well, it's just, yeah, I'm not doing this in my head right now. So let's pull it to 16. So 4 squared is 52 over 13. And I don't know why probably because it's getting late. So this is 4 times the square root of 4. So 64 it would have been divisible by. Okay, so 8 square roots of 13 over 13 looks like the distance.